Good afternoon, everybody. Welcome back to another one of our live interviews. A quick reminder before we start, as I'm sure you've all heard plenty of by now, the deadline for entries is 23rd of March. This is for our Leaders War competition. So I hope they are all coming along really well and we are nearly ready to send them off and submit them. Today we have Anna Hills from Rolls-Royce. Unfortunately, Yolanda couldn't join us, but Anna is here and we are just as excited to be accompanied by Anna, so that is great. Anna's got a short presentation we're going to go through and then we will open the floor to questions. Remember, you can pop these in the chat or also in the Q&A box. So, hi Anna, are you there?
Yep, I'm here.
Hi, so I will share my screen and then obviously you can just talk through your presentation and let me know when you want me to move slides, all right?
Perfect. I'll turn my video on as well.
Lovely.
So everyone can see me.
There we go. Okay, go ahead.
Okay, so welcome everyone. Sophie just said my name's Anna, I work at Rolls-Royce. So I thought I'd start with taking everyone through kind of the path I took to get to Rolls-Royce and get to where I am. So I took probably what most people consider a more traditional route, did A-levels, university, and then joined the company as an intern. You can join the company so many different ways. People do internships, they'll work other places first and come in later. Apprenticeships are very popular as well. So this is not the only path you have to take. You don't have to go to university if you want to be an engineer. It's just what I chose to do and it was what worked for me. So like I said, I joined as an intern. I first worked in safety and reliability. So making sure our planes are safe, making sure they don't fall out of the sky or catch fire or anything like that. Which you'd think would make me terrified of flying, knowing everything that could go wrong. Actually, it makes me feel really safe because I know all the maths behind it and I know exactly how safe things are. And then after that, I joined again after finishing university on the graduate program, moved for a few different roles as part of that. And now I'm currently working as an engineering program controller, which is a fancy word for project manager who understands the technical side. And I work in the tooling team, so looking at how we strip and build our engines and how we service them in the same way you'd service a car. It's just much bigger and takes a lot longer. So do you want to go to the next slide? So the kind of rundown of what I do. At the moment, we're looking at introducing new ways of taking our engines apart. So traditionally, you bring it into the overhaul base, and then you have to turn it on its end. And then you have to take a bit off and you have to turn it again, you have to take a bit off, and it's quite time consuming. So I'm looking at a way we could just bring it in and leave it horizontally, leave it lying flat, and do things a lot faster and a lot more efficiently to get to the bits that are really important that we need to. As part of that, we've got a lot of new tools to introduce. There's about 100 new tools for doing this. So I've been dealing with making sure those are designed correctly by our team, making sure they're manufactured. So I work with suppliers, and have to deal with things coming in on time, and there's a lot of moving parts in these things. And then we also have to validate this. So it's all very well designing and making some new tools, but you've got to prove that they work. You've got to prove that they're not going to damage your engine in any way. So that's something we do as well. Do you want to go to the next slide? And then I guess this is my last slide, really. I just want to skim through this stuff because the questions are going to be the really interesting part. But the reasons I chose engineering is basically I, at school, absolutely loved maths, and I particularly loved maths applied to the real world. So doing things like mechanics and if you apply a force to an object, what happens to that object? How fast does it move? Where does it go? That was what I really enjoyed doing. And I also like the more creative side of things and kind of solving complex problems, which both come together really, really well. And that's basically what engineering is. It's creative problem solving and doing some maths from time to time. One of the other things I liked about it was a very clear career path. So there's lots of things people do where maybe they'll do an English degree and then their job maybe won't be directly related to that degree, even if it's something they still enjoy doing. Engineering, it's much clearer. So you do an engineering degree and then you can become an engineer, which for me was something that's really attractive. I knew what I wanted to do and I knew that would help me get there. And then I just get to work on some really cool technology as well. Engineering is such a cool area. There's so much going on. And yes, I'm working in aerospace, but you could work on cars, you could work on wind turbines or solar panels or nuclear energy generation or medical engineering. it opens up this entire world, all these new amazing aspects of technology in a way that a lot of other careers don't. So that was another thing that really, really appealed to me. So that was the whistle stop tour of my career, how I got here, why I do it. So questions, I think there's already one come in.
Lovely. Yes, thank you so much. So let's get to the questions. So to start off with, we've got, has your work ever taken you out of the country?
No, mine hasn't personally. The team I'm in now, I joined just as COVID kicked off, which is a bit of a shame because otherwise there would have been plenty of opportunities to go out. We have overhaul bases who repair and service our engines all over the world. And it used to be something our team did quite often, was going out to these places and training them in new methods. That's not been happening while I've been in the team. Doesn't mean it won't happen in the future. But for now, I've unfortunately not been able to.
And when you were a child, who inspired you? Or maybe not even a child, just in general, who kind of inspired you to want to take this route and become an engineer?
Oh, I think it was a combination of lots of people. I think the first person that really springs to mind was my GCSE physics teacher. She was absolutely great. And I still remember she taught us the difference between voltage and current by having us all walk in a circle and we were the current. Someone was the light bulb and someone was a battery, and the battery handed out starburst, which is the voltage, and as we went round we would hand it to the light bulb to light them up. So that one teacher explained things in such a clear way and made it so fun and engaging. So she was definitely a big part of it. I also say my dad as well, because he originally was an engineer. A bit sappy, that one, but
no, and saying that, obviously, your family, and is everybody kind of supportive? I'm really proud that you have become an engineer.
Yeah, my family, I'm very lucky. My family are incredibly supportive of what I do. They're really, really proud. My dad still can't get over the fact that I got a master's when he never even went to university. So they're really proud of me.
That's great. And we've got, is your job demanding?
It can be. So the main project I'm working on at the moment, it kind of trundled along for quite a while. And then recently people have got really, really interested in it very, very suddenly. So it's gone from, I can kind of do things, no one really bothers me, I can just get the job done, to now I'm having to give updates to seniors on a regular basis. If we have any delays, everyone's going, what's happened? Why has it been delayed? And not in a nasty way, of course, it's always, there's a valid reason and that's okay. But it means I have to be a lot more aware of everything that's going on than I did a few months ago. So yeah, it can be demanding. It's not always. I think these things always ebb and flow.
And we've got, how can aerodynamics help the speed of vehicles?
Oh, interesting one. So
Nice.
aerodynamics, basically you're talking about drag, right? So if I was to move my hand like this and I was trying to do it really, really fast, all the air in front of my hand is going to collect, it's going to try and stop my hand moving. If I move it like this, the air can flow over and under it really, really easily. So for me, my hand's quite small, it's not going to make a huge amount of difference, but you can do this if you take a large piece of paper, hold it in front of you like this and run around outside. It's going to be a hell of a lot harder to run holding that than it would be if you don't have the paper, or if you hold it so horizontally the other way. So obviously with something like a car, if you think of a super fast F1 car, that's all been optimized. They've done their best to make it so the air flows really well over that. And in some cases, the air flowing over it can actually help it move faster. It can push it down into the ground a little bit more. And then you compare that to a lorry. They don't move particularly fast because they're big and blocky and heavy. So I think that's the simplest explanation I can give. It's basically how well your air is working against you, or it can work for you.
Amazing. And we've got, is it important that technology and engineering develop together?
Absolutely. So engineering is a huge part of technology. I think there's this quite common misconception still that engineers are the mechanics who work on your cars. And that's an aspect of engineering. It's a very important one. But if you look at what a company like Rolls-Royce is doing, we're developing new engines which are going to be more efficient. We're bringing in new technologies in terms of things like AI that can be used on engines. So they really do go hand in hand. And things will develop in terms of technology maybe outside of engineering that engineering can then bring in and use, and engineers can maybe develop new components, new bits of hardware that it's kind of pure technology. If you're talking about programming and coding and things like that, they can then use as well.
And we've got, how do you make an aeroplane engine? how many have you made, and how long have you been an engineer?
So I have never personally made one. I've watched several be taken apart and put back together around, which takes about 12 weeks if you do it sort of slowly on the methods I do where we're doing it for the first time. If you're quick, you can take one apart and put it together again in 6 weeks. And first making them, I think, is about 8. That's putting components together. Actually, manufacturing the components takes a bit longer as well. I've been an engineer since 2018 officially.
And we've got so many questions, as you can imagine, and kids are loving Rolls Royce. We've got from Wandle Valley Academy, they put, Freddie wants to know if Rolls Royce are developing any robotic machinery like self-driving.
As far as I know, we're not dealing with self-driving. I believe there's some work, or at least investigation, into vertical takeoff and sort of taxi type planes, so much smaller things. It's definitely something that I've heard talked about a few times. Self-driving, I don't think we're doing that, unless it's somewhere secret I've not heard about.
And have you driven many cars or planes, and how do you know that it's okay and safe to do so?
So I've never driven a plane. I would love to one day, but not had the opportunity so far. Drive a car to work every day, so I've definitely done that. So planes are actually safer than cars. If you go on holiday, by the time you've got to the airport, if you drove there, you've done the dangerous part of the journey. So I'm going to throw some numbers at you. But when we design an engine, there's different kinds of things that can go wrong with it, right? And some of those things we say are hazardous, and some are catastrophic. And a hazardous thing that's allowed to go wrong, it's 1 × 10⁻⁸. So it's about 1 in 10 million engine flying hours, would say. And for a catastrophic event, it's even smaller than that. I think it's 100 million or something. It might be a million, 100 million, but very, very small numbers. And that's how long it's allowed to go wrong. But even when we do that maths, the assumptions we use, we assume everything's more dangerous than it is. And we have what we call safety factors. So you go, oh, that plane can support 100 kilos of weight. They could support a hell of a lot more than that, random number. Plane can support 100 kilos of weight, but we're going to do the maths and make sure it could technically support 200, for example. So the numbers you see is actually even safer than those numbers.
That makes me feel better. We've got, what are your favourite and least favourite things about being an engineer?
My favourite is the technology I get to work on. Like I said, there's so much breadth. And at the moment I'm in aerospace, but I could take my degree and I could do so many things. This is what I'm enjoying for the moment. The second part of that question?
What are your favourite and least favourite things?
Least favourite things would be probably the assumption that people get that when you're an engineer, you know how to fix their washing machine. It's quite a cool. Or I was once in a bank and the one said, oh, you're an engineer, so do you have to know how to fix everything then? And there's still these really common misconceptions about what engineers actually do, which is fine. You know, I'm glad people ask the question because then we can educate them. There's a lot more to engineering than fixing a washing machine.
I love that. Okay, so we've got, do wheels have an effect on the speed of vehicles? And if so, how?
Yeah, so there's lots of different ways. My knowledge of wheels is quite limited because I work on the engines of the plane. There's no wheels in an engine. But if you think about the tire pressure of your car, for example, if your tire pressure is really, really low, your car has to put a lot more energy in to be as efficient and go the same speed. It basically makes you're going to be using more fuel to do the same journey. So that's the quite kind of obvious way. If you want to be really clever, you can get into things like friction and the different surfaces. There's lots of different coefficients of friction involved with rolling things. It's quite complex maths in some areas. But yeah, that's the simplest answer.
Let's have a look. And we've got so many questions, trying to pick some. We've got, how many years did it take you to get to where you are?
So my engineering degree was 4 years, so 3 years as a bachelor's and 1 year as a master's. And then it's been about 3.5 since I graduated. So I've been doing this for about 7 years now, 6 or 7. You can take other routes. So An apprenticeship is also going to be about 4 years, but you're getting the job experience alongside the education side of it. So you might get to certain levels a little bit faster, but it take a bit longer to catch up in other areas. It does vary. Some people will come out of university and be a director somewhere in 5 years. Some people will come out of university or their apprenticeship and take a little bit longer. They might start a bit slower and then speed up later. And it all depends what you want to do and how fast you want to kind of drive your career as well.
And do you think if you were an engineer today, is there anything else that you would have done in your career if you could go back and just start again?
I don't think so. I'm still quite early in my career, realistically. I'm 26. I've got a good 40 years ahead of me working. So there's still time to change. But coming to Rolls-Royce, I love engineering. I love the university I went as well. But coming to Rolls-Royce was a brilliant move early on in my career because the graduate program I did moves you around a lot of different areas of the business. So I got to see a lot of different things, work out kind of what I wanted to do that way, which everyone's different. For me, it was better than just going in for a job and realizing down the line maybe it wasn't what I wanted to do. Kind of avoided that risk.
And we've got, on a scale of 1 to 10, how fun is your job and what's your best or biggest highlight of your career so far?
I'm going to say an 8 out of 10. There's definitely days where it's less fun than others. And I think that's going to be the same for any job. Highlight I think being able to present the projects I work on to people in the company and some of our customers and having them get really, really excited about it, right? So the stuff I'm working on at the moment could save us quite a lot of money. And so we'll sort of talk to seniors and they kind of go from, oh yeah, tooling methods to, oh wait, this is really cool. This could be great. Can we do this? Can we use it here? And that's always really exciting. The other thing I really enjoy is STEM outreach like this. So Rolls-Royce has given me a really good platform to do that. And it is one of the things I really enjoy doing.
Amazing. We've got, have you developed any machinery that is self-conscious using AI?
I have never worked with AI, no. I'm not good enough with coding and programming to do that, unfortunately. Not to say I won't learn it in the future, but no, not something I've worked on.
And how long does it take to make an aeroplane engine?
I think I briefly answered this earlier. It's about 8 weeks-ish. Depends how fast you do things and how do you do it on day shifts? Do you have people working nights as well? Things like that.
And what's the kind of process from start to finish? Is it, is there somebody who has to design it and then does it go somewhere else? What's the whole thing, the whole process of it?
So if we're talking about the entire process, it's years to design and make an engine. It starts off in kind of concept where we look at the engines we already have and we say, here's what works there, here's what didn't, maybe there's some new technology that's come out since, or we've worked out how to do something a bit better and incorporate all of that. Then it goes into the design phase. We've got some really clever people who will just adjust the twist of turbine blades and things like that by a couple of degrees, or change the software and how the engine runs and make it a little bit more efficient. And it takes a long time. There's a lot of certification processes you have to go to. Aerospace is a heavily regulated industry. So there's a hell of a lot you have to do, even once you've designed the engine, to prove that it is safe to fly, even if it's similar to all of your other engines. You have to test them as well. So we do ground testing on a test bed. You basically put the engine in a big room and you run it through various different things. Sometimes we run it for hours and hours and hours to see what happens to it. Sometimes you'll start it, ramp it up to high speed and drop it again and back up and drop it again, to see how it responds to that. And then we also do what we call flight tests, where we'll put it on a flying test bed, which is just a plane, and test it there as well. And then eventually you also got to design all the tools and the methods for how you're going to assemble these engines, how you're going to service them. And after several years, you'll get to the point of this engine will be in service. I think for context, the Ultrafan is, I think, just being built now, and that was well underway when I joined the company a few years ago. So it's really been going for quite a while.
Wow. So it is a lengthy process.
Yeah, there's a lot that goes into an engine.
Yeah. We've got, are there any projects that you have done that have pushed you out of your comfort zone?
So when I was on the grad scheme, right at the end of the scheme, I had about 2 months left and kind of had reached the end of a placement. So I asked very nicely and got 6 to 8, I think it was 6 weeks in the end I spent there in central technology. And I worked on drone flight paths. So we were looking at using a drone to just document the state of engines. You fly it around and take a picture. And I had to program a drone in Python. I'd used a little bit of Python before, but not a lot, never to anywhere near a professional standard, right? So what I've been doing was stuff on my laptop at home of just experiment with inputs and things like that. And this was, now I'm going to use what little I know to control a drone, and also had to develop, how do I want this drone to fly to keep things in view the entire time. So that was a very steep learning curve. Like I said, I was only there for about 6 weeks, so I didn't have a lot of time to learn it. But it ended up being one of the most fun things I did on the grad scheme, just because it had to be so fast paced and it was so new and so exciting.
Amazing. And we've got a question from Lagoon class at St. Peter's. Do you know how to do your times tables?
I do. It's one of those things that I know people tell you to remember it and learn them, and you absolutely should. But also there comes a point where you've used them so many times, you just know it. And you don't have to think about it. I'm sure everyone's been playing Wordle recently, haven't they? If you don't know, there's a maths version of that called Nerdle, where you have to put in an equation that's mathematically correct to work out what the equation is. So if you want to practice at mental maths, absolutely do that, because it's great fun.
And the same class are asking, have you ever made any mistakes on engines or in maths in general?
I've made tons of mistakes in maths. Everyone makes mistakes. It's how you learn. Yeah, people make mistakes on engines. The important thing that I think Rolls-Royce is very good at encouraging is that when someone notices a mistake, you point it out, and that could be the person who's made a mistake go, actually, guys, I think I messed up that up there. Can we just go back and double check? Or it could be someone else saying, oh, should we have an extra look at this? And mistakes happen. We're human. We're absolutely going to make them. The important thing is you fix it.
Lovely. And we've got what airlines use Rolls-Royce engineers, if you know?
So lots of airlines use Rolls-Royce engines, and therefore we'll use some engineers for things like servicing and emergency things in the field. So Emirates use us. I'm absolutely blanking now. Air France. Yeah, I think a significant number of airlines. I don't want to just list out airlines, it's going to get really dull, but there's a lot of airlines use Rolls-Royce engines.
Lovely. And are there any aspects of engineering that you use in your daily life that you kind of, use on the job, but then also use in a personal aspect as well?
I think a lot of it is the way of thinking. So I mentioned earlier kind of creative problem solving, right? I'm actually going to flip the question around a bit. And sometimes the way we solve the problem seems really silly, but it's actually, that's what the core of engineering is finding that simple solution. So we're running a validation trial for some new tools a while ago, and one of the spanners, so it's not a normal kind of spanner you'd find in your dad's garage. It's a big long spanner that reaches inside the engine and kind of around a little bit of the corner as well. And it was just really heavy, and the fitters working on the engine didn't like it. So they basically taped together a load of extenders. And so it was completely safe. It wasn't going to damage the engine in any way, but it was far lighter. It was a little bit flexible. They found it a little bit easier to use. And it was one of the things where our tool designers immediately looked at it and went, that's a really good idea. We spend ages designing these high-tech spanners, and they've come up with a way simpler solution in 10 minutes because something was annoying them. I think that's just a really good example of that creative problem solving.
Definitely. We've got, why did you choose to be the type of engineer you are opposed to all the other types of engineers that there are?
I think for me it was almost an accident. So when I was looking to apply for internships while I was at university, I basically, Rolls-Royce opened applications really early. I was like, well, I'll put an application in there, and they offered me the job, and I enjoyed my internship, so I came back on the grad scheme. That's kind of how it's ended up. And obviously through the grad scheme tried a load of different things and found that this was the kind of area and type of role I wanted to do. Personally, I've never really enjoyed the heavily technical side of it. I love the maths in a lot of ways, and I enjoy things like CAD, computer-aided design, where you make the models on a computer, but I don't want to do that every single day. And I like that my current role gives me the opportunity to talk to loads of people. I deal with customers and suppliers. I effectively give sales pitches occasionally about how great projects are, and I get to deal with the technical side of things as well as the slightly less technical side. I always get the best of both worlds.
Lovely. We've got, do Rolls-Royce make rocket engines as well as plane engines?
We don't make them, no. I believe there is, or was, I'm not sure what the current status of it is, investment in a Sabre engine. It's been a few years since I heard anything about it, but I assume it's still happening. We don't make rocket engines as far as I'm aware, no.
And can you explain how engines work in the simplest way possible?
Simplest way possible, which some of you might have heard before, is suck, squeeze, bang, blow. So the engine sucks air into it, and then it squeezes it, compresses it really, really small. At that point, you put in some fuel and you set it on fire, so bang, and then you blow it out the other end. And that's the same way a car engine works. So in a car engine, it does all those things very sequentially, one after the other. But in a jet engine, those things are all happening at the same time in different parts of the engine.
Lovely. And have you ever faced any particularly hard challenges at all during your career so far?
Interestingly, I think one of the biggest challenges I faced was actually at university. I was working on my master's project, completely unrelated to jet engines. It was more medical engineering. And we were using flex sensors, which the idea is you can connect them in a circuit and the resistance changes as you bend them. So you can use that to tell what angle it's bent at, which sounds great. But in reality, as they heat up, those resistance values change. So obviously, when you have something connected in a circuit, the components get hot. You'll notice that if you charge your phone, it might be warm if you're using it to scroll through TikTok while it's charging. It sometimes gets a bit hot. And so they would get warm as I used them, and then the values I had would change. So I'd have to turn them off and wait for an hour to cool down, and then come back and recalibrate them and try again. And it ended up being I just had to be very, very vigilant about doing that and making sure they didn't get hot and things didn't change. But one of the other ways I found to get around that was I'd measure things in 2 or 3 different ways, which is quite a standard engineering practice. You can measure something in one way, but if that one way is wrong or someone's read it wrong, you will have no idea. So you measure it in another way as well, and then you can check them with each other. And ideally have a third way as well, because if one of them's wrong, you can't tell which one it is unless you have a third, and then you won't be wrong until the right, hopefully. So that was one way I got around that.
And what's your favorite thing about working at Rolls-Royce, and do you think you'll be there for your long-term career?
So I think my favorite thing at the moment is the team I work in are really, really great. It's just a really nice bunch of people to work with. I think whatever job you do, the people you work with are one of the biggest things that make it whether or not you enjoy it. Longer term, I'm actually looking at leaving Rolls-Royce quite soon, just for various reasons. I'm having to move away and things. But I would absolutely consider coming back in the future if the opportunity arose.
And we've got, have you ever taken part in any chemistry as an engineer, even potions?
Never done potions. That would be really cool though. So my university degree was mechanical engineering, but in first year we had one module on chemical engineering. I didn't get to do any cool science. I've not done any cool experiments really since I was at GCSE, unfortunately. But if chemistry and engineering is something that interests you and you're not sure which to pick, chemical engineering is a job you can do. I would absolutely recommend you look into that.
We've got, do you ever try and come up with totally imaginary pieces of equipment and then see if you can use any parts of that?
So actually, that's quite a common brainstorming method people use. So if you need to come up with an idea, I've done this on various training courses where, let's say you want to make a new lawnmower. I think that's the example I've seen used quite a few times. So to start with, everyone gets together and you brainstorm. The idea is no idea is too stupid. So rather than a lawnmower, why don't we just buy a sheep and the sheep can eat the grass? And that sounds silly, but we wanted a lawnmower, and sheep have other upkeep and you've got to shear them, they might have enough grass. Or then you can think about, well, the jaw of a sheep, they have teeth and those teeth cut the grass. So maybe there's something that we could use. You don't have to manually move a sheep around a field. You can just let them go and they'll do it. So maybe there's something in that we can take. So just because something seems like a silly idea on the face of it, there's probably something in there that actually would work, or you can adapt and make it useful for what you're doing.
Lovely. And we've got, I think I know this one, but is the car industry the biggest part of Rolls-Royce anymore?
No, so jet engines are one of the biggest parts. We also have nuclear submarines and small modular reactors, so nuclear energy generation. Cars are actually made by BMW.
Ah, well, the more you know.
Yeah.
And what's the largest engine you've made, if you can elaborate a little bit on it?
So I think our largest engine at the moment is the Ultrafan, and the second largest would be the Trent XWB.
Wow. Do you find that you think of an idea or something to use in one area, but then use it elsewhere? So apply it to some other kind of project or something different to what you originally planned it for?
Yes, definitely. So coming back to the grad scheme, I moved through a few different areas. And I definitely took things I'd learned in one area and applied. So I can't think of any specific examples right now, but it's something that people in engineering talk about is getting breadth in your career, right? You want to go and learn what's happening over there because it might be useful over here later on. And a company the size of Rolls-Royce, there are just, there's entire areas that I've never interacted with because my job's never taken me that way. But when I do get the chance, I would absolutely speak to them. Actually, I'm doing some work in cost modeling and how we plan like our overhaul network and things at the moment. And using that, I've taken some of what I know from tooling and been able to raise questions and things that the team wouldn't otherwise have thought of because they didn't have that experience.
And we've got obviously I know you said you loved maths in school. What other subjects did you like? Did you like science is the question?
I did like science. Those are the two biggest. I actually also really enjoyed geography. I did an A-level in that, which geography is wonderful for teaching you kind of critical thinking skills and how different aspects of the world relate to each other. History I enjoyed as well, mostly sort of ancient history. I still find ancient Greece and ancient Rome and Egypt absolutely fascinating. I mean, some of the engineering they did was incredible. The Romans had underfloor heating. That knowledge was effectively lost in the UK. We've now started doing it again, but yeah, they did some really cool stuff in the pyramids.
Exactly, very true.
Yeah.
Which engines have you made? I think you've covered that one, but which one is your favourite that you've made?
So the one I work on most at the moment is the Trent XWB. I've also done kind of a similar project on the Trent 7000. So those are the ones I've worked with the most. I can't pick a favourite between the two. They're both great engines.
And would you say your job is dangerous in any way?
No, I think the most dangerous thing I have is making sure I don't walk under an engine by accident and hit my head on it, which I shouldn't be doing anyway. So I wouldn't fit under it because there's a stand under it. So no, my job's very, very safe. You wear safety shoes when you're down on the shop floor and a bump cap as well and safety glasses. And as long as you do that, there's no real issue.
Lovely. And let's see if we've got some more questions coming in. Bear with me, I'm just trying to read through them all. What advice would you give to the primary school children watching today who would like to become an engineer?
So focus on maths because it's a really important skill, and physics as well, but all subjects can relate to engineering eventually depending on which area you want to go into. And I think you're still at primary school, you've definitely got a little bit of time before you need to start panicking about these things, but when you come to picking your GCSEs and your A levels, make sure you're focusing on your maths and your physics and those kind of core subjects. And like I said earlier, there's a lot of different ways of going into engineering. You could do university, you could do an apprenticeship, maybe eventually see if you can get some work experience. The world is your oyster with engineering. You can do so many things.
Amazing. And we've got there's a couple more coming in now as well. So we've got, what materials do you use to create engines?
There's a lot of steel, massive amount of steel. Various different alloys depending on where you are in the engine. There's little plastic clips and things on the outside. Probably you name it, we've used it somewhere. A
huge variety of stuff.
Yeah.
Everything. We've got which is quite an interesting one, this one. Has anybody ever told you you couldn't be an engineer because you are a woman?
I've never had anyone tell me that. I know people who have, unfortunately. Those, people do still think that for some reason, I don't know. It's not like women in engineering is a new thing. We've been doing it for centuries. Yeah, never let anyone tell you that, because it's just fundamentally not true.
Lovely. So that is the end of all of our questions for today's interview. We had literally so many. I'm glad we've got through the majority of them. Thank you so much, Anna, for obviously giving us your time today. We really, really appreciate it. And it's been great to hear about everything you do and about how Rolls-Royce supports you. So thank you so much for that. Thank you to everybody.
Thank you very much for having me.
Yes, thank you. And thank you to everybody who has joined us and watched. One more reminder that the deadline is March 23rd. So please get your entries in by then. And we hope to see Anna's name on some of them as the inspiration behind the design. So thank you so much, everyone. And remember, we've got another interview tomorrow morning at 10:30. And we hope you all join then. Thank you so much, Anna. Really, really appreciate
Thanks, everyone.
it.
Bye.
Thank you.